Hi guys, welcome to my YouTube channel. Don't forget to subscribe and share.
Hai, Assalamualaikum. So now let's have a quick revision for subtopic 4.2 and 4.3 in chapter 4 biocatalysis. So for subtopic 4.2 cofactors, so cofactors is a non-protein component required for some enzyme to function. Remember, cofactor is non-protein component that required for some enzyme to function and have three types of cofactor: metal ion activator, coenzyme, and prosthetic group. And for each of these types, you need to remember the type of the cofactor, organic or inorganic, the types of bonding with the enzyme, the function, and also the example. Okay, before that, if the enzyme without cofactor, we call it as apoenzyme. And after the enzyme bind with cofactor, this is referred to haloenzyme. Okay, so this cofactor will bind to the enzyme at usually the allosteric site lah. Okay. Alright. Now this metal ion. Okay. Metal ion activator. The type is inorganic and it will bind loosely and temporarily by forming weak ionic bond. The function is to draw electron away from the substrate molecule, making bond less stable and easier to break. Example is amylase. Okay. The example is chloride ion, which required by the amylase. Okay. Second is coenzyme. This coenzyme is organic substance. Okay, it also bind to the enzyme by forming loosely and temporarily binding by hydrogen bond. Okay, the function is to transfer electron or part of substrate from one molecule to another. Example is coenzyme NAD+, which required by enzyme dehydrogenase. And the last one is prosthetic group. This prosthetic group is organic molecule and it will bind to the enzyme by forming tightly bound and bind to the enzyme permanently by covalent bond. It binds tightly bound and permanently attached to the enzyme by covalent bond. Okay, the function is to act as carrier of atoms or electron. Example is the heme group in cytochrome oxidase. Okay, so for subtopic 4.3, inhibitor. So what is inhibitors? It's a substance that bind to enzyme and can cause the enzyme to decrease or stop the enzyme activity. Okay, the substance that bind to enzyme and decrease or stop the enzyme activity. So this inhibitor has two: revisible inhibitor and irrevisible inhibitor. For revisible inhibitor, it will bind to enzyme by weak interaction or bond. So mean it will give a temporary effect and it will not cause the enzyme to have permanent damage. Removal of inhibitor restore activity of enzyme to normal. And for this revisible inhibitor has two types: competitive inhibitor and non-competitive inhibitor. For competitive inhibitor, it will bind to the active site of enzyme, but for non-competitive inhibitor, it will bind to allosteric site of enzyme. Effect of binding, okay, when this competitive inhibitor bind to the active site of enzyme, it will block or prevent the substrate from bind to the active site because this inhibitor bind to the active site since it has similar structure to the substrate, so it is compatible to the active site. Okay, compared to non-competitive inhibitor, the effect is when it binds to the allosteric site of enzyme, it will cause the active site to change conformation. So this active site is not compatible to the substrate. So substrate cannot bind to the active site. Okay, so their reduced inhibition effect. Okay, this inhibition effect can be reduced for competitive inhibitor by addition of substrate concentration or increased substrate concentration can reduce the inhibition effect, because when high substrate concentration, high chance of substrate to bind to the active site compared to the inhibitor. But in non-competitive inhibitor, increase of substrate concentration will not give any feedback. Okay, dia tak boleh nak bila kita tambahkan banyak substrate pun, it will not reduce the effect of the inhibitor. Example of competitive inhibitor is the competitive inhibitor is malonic acid, and for non-competitive inhibitor example is isoleucine. Okay, here is the irrevisible inhibitor. The mechanism is the irrevisible inhibitor will bind tightly and permanently to the enzyme by forming covalent bond. So it will cause permanently damage to the enzyme. Removal of inhibitor restore the activity of enzyme to normal. Okay, ini kita tak payah ambil lah point ni, okay. Sebab dia kata dah tadi permanently damage. So sekejap saya cancelkan point bawah ni. Okay, so this one tak payah. Okay, alright. So here is the example lah. Okay, here is the irrevisible inhibitor bind to the active site, and then what happen? It will bind to the active site permanently. So until forever, this substrate cannot bind to the active site. Okay, example of irrevisible inhibitor, for example, is cyanide and heavy metal element lah, mercury. Okay, so that's all for the quick revision. Thank you.